moment, so to allow the pilots to access the training later on. And maybe we'll have further opportunities later, maybe through the academy or other platforms within Iliad to share what had been made so far during all these internal trainings. So thank you again for your participation and your interest for this training. Just to a quick reminder that this is the result of the first assessment we did, thanks to all the pilots on some needs. Some were very specific, like this one for fisheries and aquaculture, while other needs, like for manager purposes, were quite general ones. And there is fortunately already ongoing work even within the other working packages. But within working package 10, we are mainly concentrating in task 10.4 on dedicated session for the pilots. So feel free to ask questions, to highlight maybe further needs, even for other trainings, because we will be taking this into consideration and looking within the consortium, like Nimrod is doing right now. I mean, they are providing a lot of effort and great support for this very specific training. So I pass the floor to the colleagues. We will be starting. Of course, it's a dynamic process, so we are like an internal discussion within the Iliad family. So feel free to interact, to ask questions, and we are here to provide support. Issam, you have something to add?
Yes, thank you, Anis. Just before the colleagues start presenting and start the training, just one word, a small word with you. I want to bring to your attention that this training session is dedicated for pilots. And if you have any further need, that the pilot have any further need in 4 of the aspects, managerial or business or technical, or the 4th one, which is marketing, if you have any just feel free to email us, or it is already in the shared folder in Iliad in a table. And this is the second training, and it will be a series of multiple training started from the last week with ASCO, and this is the next training, and it will be a continuous set of training all along the project duration. So if you have any further need, so feel free to let us know. And thank you.
Thank you, Issam. So let's start this training about involvement of fisheries films in digital community and the use of satellite data and specific services. Dear colleagues, the floor is yours.
Thank you. So let us present ourselves. My name is Răzvan Matescu. I'm oceanographer working in an MRT. It's a shortcut of National Institute for Marine Research and Development, placed in Constanța, Romania. This is Western Black Sea shore. And we shall have some presentation about certain application of, let's say, user case for the Black Sea. It's a CMEMS user case designed for Black Sea. Because we had this list of pilots of training, a list of stakeholders, we had to little bit rearrange as we talk about rearrange the presentation. And tomorrow we shall have a shorter one, shorter part, and tomorrow. So today we shall have a shorter presentation, and tomorrow we shall have additional one due to this reconfiguration of this presentation. So I'll make a share screen for this. Can you see?
Yes, we see it.
Yes,
Thanks.
Razan, it's okay.
Okay, it's full screen, or I have to make something.
Yes,
It's not
maybe
full screen yet.
Something like that. I don't know. Maybe now.
Yes, right now it's okay.
Okay, so we have this training called named Engaging Fishery and Aquaculture Enterprises in the Digital Community and Utilization of Satellite Data. And based on this title, we shall have an agenda described on the Iliad project webpage. So today we shall have this presentation and certain Earth observation services for fisheries and aquaculture. Some product overview. Probably already know about almost of us, almost of participants from CMEMS data portal. And also we shall have a presentation of these use cases in Black Sea related to fishery and also aquaculture in this area. Even it's a difficult area with strong exposure in this Western Black Sea. We had these two projects called Skyfish and Forecoast, supported by CMEMS and the European Commission, respectively. And based on these use cases, we shall have also tomorrow approach. We can have as your preference to have let's say deeper continuation and based on your questions, we can have a continuation in deep tomorrow. So as an overview, this the objective of the training was to enhance our understanding on the ocean observation application for fisheries and aquacultures, and improvement on the forecast in this regard. So beyond this response of the main question, where is the fish, and we know some mobile application with this name, and sure the theme of present present technique training will include information on the role of Earth observation and the regional environmental condition prediction associated with this better economics and better on several tools related to these specific activities related to fishing and aquaculture. And these practices, associated practices with Earth observation technologies, including access and Earth observation application with specific CMEMS downstream services example in the region of the Black Sea. So based on our experience, we can have an introduction on specific technologies related to fisheries and aquaculture, and probably the pilots in other seas related to these domains can be improved as well. As a reference, we start these use cases a long time ago when with support of Romanian Space Agency in STAR programs of founding research for research projects. And as a reference from the starting point, we have as a let's say as a background the knowledge described in this report of the International Ocean Color Group, and based on this we approach also these ecosystems, climate change related to fisheries, and variability of productivity in an enclosed sea as a Black Sea. Also different application in stock assessments, and also for research management application, and as I told you, these tools designed for better fish harvesting, and in this case the fishermen can have better tools to achieve their goal in better ways. And also for marine aquaculture and this fishing management also was involved. As you know, or you already know, the second base of our approach was these European programs designed for different specific services related to various activities. In our case, fishing and aquaculture. In our case, this is about safety, marine safety, food, something like that. Can be classified like this. So having as a beneficiary of this service provided by Copernicus program, so we also have various data sources related to marine and ocean processes involved in this. So as you already know, that we have this let's say data portal with a lot of ocean products and data and sure coverage for all European seas. And about this, we can access these satellite observation products in conjunctions with model products, and the let's say in situ observation are not quite very well developed in several seas. In our case, Black Sea, it's the poor developed observation network installed here, and because of this, we have a lot of benefit from this model extension provided by CMEMS, so this Copernicus Marine, and based on this, we use several parameters related to save marine food, and to application related to fisheries and aquaculture. So first of all, we benefit from a temperature model data, but also in situ and observational satellite observation data. About salinity was even there is a satellite, as most everybody knows about this. The reliability of the data, it's still in a developing stage, and among the other activities, we had here in Black Sea an extension of ESA support related to upgrade the knowledge level in this regard. So here we had an improvement of salinity fields after the project AO4 SIPS, if you know. It's related to scientific support of Earth observation in Black Sea. So AO4 SIPS. It was a project, and based on this advanced, probably the salinity fields and salinity data, especially that in this case of Black Sea, we had and we have always a strong input from fresh rivers from the northwestern basin, and based on this fresh input, the aquaculture, especially aquaculture, can have serious problems related to harvesting and the productivities, even with strong mortalities when the salinity decrease below 10 ppс, let's say. So 10 grams per liters of salt. Also, we had the benefit from turbidity and transparency, also primary production in relation with nutrients and oxygen, but also the main data used was phytoplankton and the chlorophyll. As you already know, the main let's say parameter obtained in ocean color data is the chlorophyll A in relation with phytoplankton and primary productivities. So based on this data, and we can find this data in tomorrow visit of CMEMS data portal. So based on this, we extend several use cases in Black Sea, and 3 of important projects designed here with Earth observation data and Earth observation application, including also marine forecasts in the Black Sea. So we're designed 3 projects. First of all was ice swim, the second one skyfish, and the third one, the last year was finished. It was the let's say Four Coast project. First of all, about this geographical characteristic of Black Sea is this semi-enclosed sea with let's say a big depth, not very big like the ocean, but at least it's we call this sea a heavy sea, because it's very and strongly stratified, and because of these characteristics and these particularities, it has a special dynamics, and the basin circulation, it's anti-clockwise rotation, and also due to these fresh inputs in the western Black Sea part, it's also a special dynamics against the very small narrow connection with the planetary Mediterranean Sea and the planetary oceans through Bosphorus Strait. So having this specific, let's say, specific characteristics, oceanographic characteristics of the Black Sea, we also considered these socio-economical characteristics around Black Sea, because some numbers say that millions of people live here in this catchment area, and also it's a small sea, it's sometimes very crowded. Now it's also war zone, as you know. And based on this, AES recordings, multi-annual recordings on this area, you can have an image of the degree of pollution, even noise pollution, and about fishery for the economic exclusive zone of Romania, we can have an image of a very crowded and very high exploitation of fish stocks, and you can see in the right part of the slide also very crowded exploitation and very crowded area in the front, close to Danube mouth. So these fresh inputs and with high productivities, biological productivities, with sedimentary beds and a lot of trawling activities during a year, it's happened here. So we consider the fishermen should be interested, even should be interested in our products and but as you already know, probably a fisherman is a tough guy, and sometimes you have to approach in different way with a specific language, and you have to address to his needs in a special manner. So that's why we put this problem at the last meeting in Rome, and sure, one of our colleagues said that it's better to involve the fishermen in citizen science activities. So we shall consider this, because after that the results of these 3 projects will be better approach from this. So I will start to talk about three projects. First of all, this project supported, financed by European Commission in Horizon Space, and started in 2019, finished last year. So we have this Earth observation service for wild fishery, oyster grounds, restoration, and bivalve mariculture along the European coast. In case of Black Sea, we have this mariculture, bivalve mariculture. So we have here several fish, aqua farm, and also fishing trawling activities. As you know, this area with representative applications. So this research institute of NMRD is under coordination of the Ministry of Research and Innovation, and based on this, all the research knowledge and let's say knowledge achieved within a research project are used for better management of marine living resources, but also extension of different marine strategy plans, implementation, also all kind of networks, and including fishermen and aquaculturists, let's say, networks are supervised by such a research project under the different consortia, and also under the specific conditions related to the economic and socio-economic development in the area. These guys were working in the forecast from the National Institute of Marine, but the consortium was quite large, and from Romania were involved 3 partners, my institute, Terrasigna, and a CMOD company. It's a specific company for hydrodynamic modeling. And about these pilots in the Black Sea related to mussels cultures, this was a service provided and based on the biophysical models and remote sensing and observation data. Also aim to promote and develop this mariculture, mussel aquaculture in this Western Black Sea area. NMRD operates this shelf aquaculture demonstrative center, and based on this center of demonstration, several small enterprises were developed, and we hope that this will be better represented in the future. As I mentioned before, the sea is very tough, and the Western Black Sea basin, the Western Black Sea coast, it's quite highly exposed to different wave attack and let's say storm conditions, and the sea, because the sea looks like a pool, it's very easy set up to have to each stronger winds from each part, and you can have different let's say train of wave in very certain area, and very easily set up. So based on this project, based on this in these activities, the forecast project was developed, and also several data, Earth observation data and model data, especially in hot season, let's say durations, because in the winter it's very difficult to maintain such activities, and the winter it's quite sometimes the sea is frozen in the shore banks. But this in this hot summer and spring, summer, autumn, the activities of aquaculture can be developed, and based on the data of temperature, salinity, currents, also wave and chlorophyll data can be developed, having the support of these European Earth observation platforms. Related to Black Sea, Marine Forecast Center of Black Sea are based on model NEMO model extensions for entire basins, and based on this data for entire basins, nestings approach were developed by CMOD enterprise, small enterprise, and CMOD was running this everyday running since 2019 until the present. And tomorrow we can have a look on the results placed in the in the Forecast project website and let's say IT platforms, data platforms. All this is configured especially for a specific area of Western Black Sea coast, and the area, it's an area of Constanța and south area of Constanța. You can see the setup process and the refinement obtained on this model, this NEMO model results. Based on this, a pilot 7 called 7 in the Black Sea was designed and was developed, and based on these local changes related to mussel farms, environment threats, and the modeling challenge related to model resolution was developed gradually, and NMRD providing this process the validation data during 3 years, almost every month, monitoring data in specific points. You will see the network immediately. So the challenges here was unclear legislation about mussel farm development, so some seasonal operation related to, let's say, coastal protection and sediment extractions operation in the area, but also some environmental threats, including extreme temperature. As I told you, sometimes in winter, it's the sea temperature going below 0, and due to freshwater input from the north, from the Danube, a lot of shore length, it's frozen sometimes. But also we have here as an environmental threats, summer water pollution, river, and all these river plume inflows. Based on this, overpassing these threats, the pilot 7 was achieved different and specific results based on also in biogeochemical models of CMEMS developed by Marine Forecast Center in the Black Sea. The model, the biogeochemical model is called NEMO Bambi. It has, as you see, 3 kilometers resolutions, starting from all basins and 31 vertical levels, gradually, let's say, refined in a nesting model approach to 1 kilometer and 59 levels, and in case of Euphoria. But this modeling is running since 2019, and at the specified web address, you can find some results in configurations, and based on the user request, it can design and for specific applications. In this case, we have some results related to chlorophyll and oxygen, and based on these fields, let's say flow fields, an owner of such aqua farm can develop some specific operation and can evaluate its productivities, ensure the rentability of such effort. So based on effort per tons of mussels, you can can have an idea of the profit involved. And sure that the pilot model have the support of validation activities and data campaign related to CTD, chlorophyll, oxygen, so multi-parameters CTD measurements, and also IDCP measurements, and also some drifter campaign in the around the Constanța port, and inside the port it's there are some area with let's say outfalls coming from and probably sometimes polluted area of can sometimes these outfalls can be overpassed during hot season because of extra water and overpassing of biological step of the power plant. So a lot of water goes directly after secondary step, mechanical and chemical epuration, and the biological step. It's sometimes it's passed without due to doubling or triple quantity of water during summer. So this in this pilot, the several models and some trajectory were designed, and some attached to the model. Particle tracking module was attached, and based on this was obtained some thresholds and alarm related to overpassing of specific and important parameters overpassing. Let's say alarm for overpassing of salinity or chlorophyll, and sometimes this current speed. But it has to be much more emphasized the alarms for specific pollutants, and here we talk about chemical pollutants, but also biological ones. Due to some touristic beaches around the area of interest, and in this case pH values and temperature can have on specific thresholds for and alerts beneficial for aquaculture firms placed here. And based on these parameters, some level of alerts can be, let's say, set up in a small automatization of 3 levels. And because of these alarms, even aquaculture owner cannot be intervened too much, but at least can be the user, the consumer of the products of aquaculture farm can be protected. So as you see here, this we have here a red dot in the image of right down right part. And this is also a second outfall of Constanța coming from operation plant existent here, and the polygon, the yellow polygon, it's the aqua farm. So sometimes these alarms are quite useful, and sure that the validation better emphasized support for this project results in this pilot project of forecast. The forecast now it's closed, but its platform was still in ongoing stage. It's sustainable platforms, and for these oysters and mussels of aquaculture can be useful. And the owner of that area is that aqua farm placed in the area of interest are open person. It's quite a lack of the project, and his feedback was, let's say, positive. A second project developed in CMEMS with CMEMS support was this iSwim related to water quality monitoring in the Western Black Sea coast, and this was the joint action of two partners. So it was Action Modulars, Portuguese company, and national NMRD. So in relation with also marine having as a result a dynamic web page based on mobile-friendly decision support. Providing this decision support system in order to enhance the management, monitoring, and forecast of the betting areas of Mamaia Bay. Mamaia Bay is also area in north of Constanța, and based on this project results, a lot of the benefits for the user was that advised user of the beaches in the matter of water quality, and also help national and local authorities in the management of bathing waters and recreational activities during hot season. Here in Black Sea, the hot season, summer season, it's only 4 months, let's say, since May. This year is not probably to swim in water because now it's 15 degrees, but it's supposed to mid-June the touristic season will start, and the extension of it is only 3 months. So we have June, July, August, and in September, let's say, so we have 4 months of these recreational activities, and such systems design as a complex flux of data integration coming from data acquisition inside, so in situ data acquisition with input data from CMEMS related to ocean circulation. The model was a CMEMS downscaling forecast involved, and also several data preparation involved in this automatics designed by active modulars. In the present, active modulars, it's not active anymore in this area, but the results of them activities remain, and this analytics and visualization access through mobile friendly website is still the iSwim was the subject of hacking, and in present there is a recovering process, and it will be active at least in 3 months, and hopefully before the starting of summer season. its result was a decreasing of spectacular decreasing, let's say more than half of casualties due drowning during this hot summer. So the input and output data sets are related to especially for forecast physics data sets of provided by CMEMS, also sea surface temperature, and also wave forecast provided by Copernicus through the specific model application, NEMO, and these WAM models implemented in the Western Black Sea basins. And based on this, the output are specific for these three domains of modeling of nested models, and also for as a result of the projects, the web page contain also several images from 3 webcams. So these are data acquisition and collection from different sources, including CMEMS data and but also in situ data. Are first of all in the domain of interest, also in aquaculture, in fishery, because when the ice stream was stopped and due to this some ransomware, the awareness comes from specific users of coming from research area, but also from fishing area. So the project results was also in various beneficiary area, but not only in research. Also, the Bywatch was alerted, and also water authorities from this regional area was also not very happy about this stopping, this ice stream stopping. So we arrived to the third project developed here in the area, and because we have together here with us Sorin Constantin from Terrasina, we can ask him to bring some details on this project developed by Terrasina and by Sorin himself. So, Sorin, if you can add some comments on this, please.
Thank you.
Continue. Thank you.
Thank you, Răzvan. Good afternoon, everybody. Thank you for your presence, for your interest in our activities. I will try to have a brief intervention today, another one tomorrow regarding Skyfish. Why? Because the Skyfish, the platform that I'm going to talk about, is the foundation which we are using in order to build our pilot case in Iliad. As Răzvan already mentioned, our pilot case relates to fisheries in the Black Sea. So I'm going to discuss a little bit about what we have so far, what we did in Skyfish, and maybe tomorrow we're going to discuss a little bit more about how we're planning to improve all this, how we're planning to move forward within Iliad. So let me just share my screen. Just 1 second, please. Okay. And if you could please let me know if you can see the slides in full screen. Everything is okay?
It's okay.
Razvan?
Yes,
It's
yes.
okay. It's very
It's okay.
visible.
Okay. Okay, thank you. Okay, so again, my name is Sorin Constantin, and I represent Terasina, which is a Romanian private company, and we are specialized in geospatial services development, mainly based on Earth observation data. As I mentioned, I'm going to discuss about this platform that is mainly based on Earth observation on Copernicus Marine Service data that we developed in collaboration with our colleagues, with Razvan and his colleagues from Constanța, and which is basically designed for fisheries and aquaculture activities support in the Black Sea. That doesn't mean that it cannot be replicated in other areas. It's just that our model were initially calibrated for the Black Sea. So what is currently operational is for the Black Sea. Okay, a little bit about the legacy. So the project was called, in fact, Service for Water Quality Monitoring for Sustainable Fishing and Aquaculture in the Romanian coastal area. We somehow expanded the area of interest, as you can see in this map. We went towards Ukraine and Bulgaria also. We had two phases. The first one happened a couple of years ago, between 2017 and 2018. It was founded by the Romanian Space Agency through the Space Technology and Advanced Research Program. And during this initial phase, we designed the first tools, the first concept of the platform. And then we had the opportunity to support the further development of the platform between 2018 and 19, since we got some funds directly from CMEMS, which is the Copernicus Marine Service, one of the big services of the Copernicus program. And we had the opportunity to further develop this Skyfish platform as a downstream CMEMS service, which is pretty nice. Okay, the project consortium always remain the same team, Terasina and the National Institute for Marine Research and Development. The distribution of activities, I would say, remained almost the same throughout the years, meaning that our colleagues from Constanța provided support in terms of expert knowledge regarding fisheries and aquaculture and in situ data for model calibration, while we at Terasina were in charge of the technical development of the platform and development of the models that we are using in order to produce added value products regarding fisheries and aquaculture. Okay, the initial context, which still remains to some extent valid even today, we had two big, let's say, issues. First, the aquaculture potential was underexploited and is still underexploited in the northwestern basin of the Black Sea, and the fish stocks were decreasing, maybe also because of decreasing effort regarding fisheries, because we do not possess a very large fleet for fishing. So, but anyhow, fish stock decreasing, fewer vessels, that means, of course, longer search time, increased cost, and so forth. Okay, and some of the challenges that we are facing regarding the fishing and aquaculture sector in Romania. So we have lack of tools to assess the suitability of particular areas for aquaculture farms, and all of these challenges we try to mitigate through our service, through Skyfish. Also, the presence of areas with high concentration of fish is seasonal, and it would be nice if we could find a way to know where this high concentration might be, because you cannot really tell for sure, but you can build a probabilistic model to this regard. and the large distances between zones with high fish resources and collecting centers. This is another issue. So you have to really know to plan your route in order to be more feasible from economic point of view, and the outdated technology, which I already mentioned. So how we have old vessels, not a lot of new technologies. Okay, very briefly regarding the platform itself, I'm going to, at the end, I'm just going to show you briefly what it's just a geo portal. You'll see very straightforward with layers of information. How does it work? Or this is the, let's say, the most important part. It's something that it's operational, meaning that each day, once per day, it goes and it updates all the information that we serve through the platform, meaning that it takes the newest data sets from CMEMS, process them, and provides to our users, let's say, the latest available information. What I would like to mention here is that apart from the possibility to use Skyfish, and the future, of course, I'm saying Skyfish, but because this is what you have operational, but I want you to think as, let's say, the next Iliad pilot case for fisheries in the Black Sea. So apart from being able to use this as a decision tool to find the most favorable fishing areas or aquaculture areas, it also can be used as exclusion zone finding, let's say, in order to, for example, to avoid bycatch. So it depends. The mechanism, the overall mechanism is the same. It all depends on the species that you are targeting and the models that you are developing, and you can use in different contexts this sort of tools. So if you are interested in finding, let's say, a particular fish species that you want to catch, you can use it if you have the right models, the right products. But using the same architecture, the same overall platform, let's say, if you have the right models, you can also provide information regarding avoiding bycatch. I don't know, dolphins or any other species that you would like to avoid. Okay. This is, let's say, the another schematic point of view of the platform. So on the left hand side, you have some of the functionalities like the measure tool, the calendar in order to navigate temporarily through the layers of information. You have profile tools, get info, mark catches, feedback, and so forth. And then you have a long list of information, layers of information that you can find in the platform, from contextual information that do not change, like the general currents model of the area, undersea features, or the bathymetry. Then going through modified CMEMS products, which are basically essential oceanographic parameters like salinity, temperature, chlorophyll concentration, and all these that are listed here. And finally, what's, let's say, the most important are the added value products. And here we have two types. In Skyfish, we have two types of added value products. One is related to fisheries, and this one we are going to further develop and refine within Iliad, and we call it Habitat Suitability Index. And I'm going to discuss a little bit more about the Habitat Suitability Index tomorrow, where I'm going to also provide some examples on how we calibrate it, let's say the regional model based on in situ data. And we also have a long-term composite, monthly composite for aquaculture, which is basically more or less built the same way as the one for the fisheries, except that the environmental envelopes that go inside the model are specific for mussels and mainly bivalves. Okay, and this is just some products example. This is chlorophyll concentration. I'm not going to stay here much longer. I would like to show you Okay. The platform itself. Okay, Razvan, can you please let me know if everything looks okay?
Yes,
on
yes, it's
screen?
okay. Excellent.
Yes.
Yes, yes.
It's
Okay, great. Okay, so basically this is the platform. As I mentioned, very user-friendly, straightforward geoportal. Okay, on the left-hand side, we have the list of products. So for example, we have waves, forecast, chlorophyll concentration forecast. These are based on models. We have roughly 10 days of forecast because this is what CMEMS provides. Salinity, seabed temperature, and upper layer temperature. Again, from models, and we have also forecasts. And then we have, these are all daily products. So for each day, you have one product. And then we have the analyses, which are this time are based on, we have chlorophyll and sea surface temperature. I'm going to leave aside for the moment the suitability indices, both of them as I mentioned. And we have also chlorophyll concentration that was measured. Of course, we don't have forecast for these products because this is not modeled, it's observed information from satellites. So you can check sea surface temperature, for example, you can check also based on models and also based on sea surface temperature. The bad news is, of course, for observed products, you only have maybe the current day information in the evening. So you can check what happened yesterday, 2 days ago, or things like that. But you have the forecast based on models if you want to look in the future. Okay, and then you have some contextual information, such as the extent of the area of interest, aquaculture restrictive areas, just briefly some anchorage areas where you cannot put such farms. Okay, bathymeters, contour lines. I'm not going to capes and islands. Okay, currents model, and that's it. And you have finally the background. You can switch between a couple of options, 3 to be more precise. Okay, and apart from the information, you have, as I mentioned, the tools, the functionalities that you can, let's say, use in order to interact with the data. So I don't know if I'm going to, let's say, I would like to know in a particular spot what is going to be the evolution of the salinity in the next 10 days. I just go here. Oops, because, okay, products graphs. I just click on the location that I'm interested in. Select salinity, select the period of interest. Let's say I want from, okay, today until the 24th of May. So it's going to provide me with a profile, a temporal profile showing the evolution of salinity. Unfortunately, my internet connection is quite unstable, so take some time. Okay, so here it is. You can also compare two products. For example, if I want to compare the forecast of salinity with the forecast of temperature in the same location, again for the same time period, it's going to provide me the evolution of both parameters in parallel and a scatter plot between the two. Who knows, you might want to see them also scatter plots depending on the parameters that you are choosing. Okay, waiting and waiting and waiting. What I would like to mention is that within Iliad context, this waiting time is going to be reduced to almost 0, because if I understood correctly, we are going to use DIAS environments. Currently, the platform is hosted by our own server in Bucharest. So if we're going to move everything, all the functionalities within a DIAS environment, then we're going to discuss about much faster response. Okay, so as I mentioned, the two parameters in parallel, the evolution, as you can see, it is forecasted that the temperature, oh, I've selected more than larger period, starting 16th of April. Anyhow, you can see the evolution of both parameters. Okay, you can measure areas, you can measure lines, basic functionalities, you can zoom into the extent, and you can switch between English and Romanian if you are Romanian. Most of you are not. Okay, you can write directly your coordinates and go to coordinates, and I think that's it for the moment. It doesn't have a lot of functionalities, just the basic ones. And of course, one important thing, all this information are served as geospatial, standardized geospatial services, meaning WMS, WFS, WCS. So you can basically, see these layers of information within your own system. You basically, I don't know how many of you are familiar with OGC standards, but we are using OGC standards, which is also is going to be used in Iliad, of course. And that's it, I think, for today. As I mentioned, tomorrow I'm going to discuss a little bit about the suitability index. Currently, for the fisheries part, in fact, I can show you for the mussels, because this is not going to be treated in Iliad. We have, I forgot to mention that here down under we can, if I scroll and I can move, I can navigate through temporal coverages. We have the mussel suitability index as monthly products, just for, if I remember correctly, 20 years or something like that. And basically you can see the level of suitability in particular areas for mussel farms. The same concept is valid also for the whiting suitability index, but this we'll discuss tomorrow. This is for fisheries. For now, in Skyfish operational, we have just one species, whiting, but it's going to change in Iliad. That's one of the main advances and refinements that we are taking care of in Iliad. Refining the models, including for whiting, but also developing for other fish species. So if you have any questions, please let me know.
Okay, thank you. And it seems that also Bulgarian can access these platforms and can be very useful for Bulgarian fishermen, also Bulgarian aquaculture farms. And we have colleagues from Bulgaria, a colleague from Bulgaria. Thank you, sorry.
Welcome.
Anis, if you want, we can stop at this moment, and we can have a second session in addition with the scheduled one tomorrow. So if you have a specific question, you can
Razvan, if I may, because I already discussed a bit the Skyfish and we are already, let's say, in the subject, maybe you can make a short poll with the current participants, if anybody wants to continue today. So I will finish with the suitability index also for whiting today.
Yes, as you
Yes.
prefer.
I don't know.
If you want to,
if you wish, we still have time in any case, and we still have time for questions.
Raise his hands. You want to ask something, Isam?
Yes. Thank you for the presentation. Yes, go ahead, Anis. Then I will follow up on him.
No, it's okay, Sam. I was just mentioning the proposal from Sorin. I think yes, we can continue because we already got this first overview on Skyfish. So maybe let's
Should we
continue
make
on
a
that.
poll? I mean, whoever
Yes.
wants to continue, raise their hands. I don't know.
In any case, it's dynamic. I mean, people can interact. So feel free. Otherwise, we'll have some Q&A after this. And myself, I have some question, but I prefer to see the audience also from their side. I think we can go ahead. How time it will need? From your side, sorry.
I think I can manage to do it in 10 minutes. No problem.
Okay. So let's go ahead. Okay.
Not very
Good.
complicated. Okay, so going back to my slides. Okay, everything looks nice.
Still not
Full screen.
Not yet.
No, we don't see the screen.
Ah, yeah, because I stopped sharing. That's why. Share screen. It was good, but only for me. Okay, what about now?
Just put it on
Now it's
presenter
okay.
mode, and it will. Now it's okay.
It's
Great.
okay.
Okay, perfect. So, habitat suitability index. Whiting or any other species, the concept is the same. It's not something new. It's something that also others did in the past, and it's based on environmental envelopes. What does that mean? It's a fancy name to highlight the environmental conditions for a particular fish species. So, for example, you can see here on the right-hand side some graphs showing these are in fact the environmental envelopes. So, for example, the first one, right-hand side, top. So this basically represents the environmental envelope for whiting regarding temperature. What does it mean? So up to approximately 1 degree, not favorable. Between 5 and 16, approximately, optimal conditions. Then above 22, if I remember correctly, it's again not suitable. And between, linear interpolation, very simple. Okay, so basically what we do is define these environmental envelopes based again on expert opinion regarding that particular fish species. And we determine this sort of suitability index for each parameter. So we have for temperature, for salinity, and for bathymetry. This is, let's say, the initial model that is currently operational. We are currently working not only on adding more fish species, but also on improving these models by adding more environmental parameters apart from salinity, temperature, and bathymetry. Okay, so good. This is, let's say, the first step where we define these optimal, less optimal conditions. And then we have to, let's say, somehow combine all this. If we have 3 or 5 or whatever, how many parameters we have to combine all of them somehow in order to come up with a combined habitat suitability index that incorporates the information coming, let's say, from all the indicators. And how can we do that? Because it's not that easy. So fortunately, we had at our disposal survey and fishery data, which were collected by our colleagues from Constanța. Several years, many campaigns, a lot of information, 238 measurements. I think now we can update because probably there are also newer data. Why are these profiles, these in situ data useful? Because we can use them in order to calibrate. So we use them in the following way. So first of all, we have to define, let's say, what we are looking for. So what we are looking for is fishing efficiency. So basically, it's not the model. What it provides a probabilistic idea about how good a particular area can be for fishing. I mean, how good that particular area is suitable in terms of habitat, in terms of environmental indicators for a particular fish species. So to this regard, we first define a measured fishing efficiency, which combines the catch in kilograms, the distance covered, and of course the time spent in order to do the fishing. And then we match up with all the satellite Earth observation derived products. In our case, for the operational model, temperature, salinity, and bathymetry. And then we have to combine all these three parameters. Okay, how can we do that? We can do that through a weighted average, but we don't know the weights because that's something that not everybody knows. I mean, you don't have this information in the literature from the experts. You don't know if, for example, the temperature is more important than salinity in particular conditions, or the salinity is more important than bathymetry, and so forth. So we try to calibrate a probabilistic model. So this is basically an iterative approach. We test all the possible combinations with different thresholds, and finally we come up, based on in situ data, we come up with the best, let's say, weights in order to approximate the probability that a particular area, pixel in our case, is suitable or not to be fished, or not to be fished, but to find a particular fish species there. More or less, that's everything. So then we go further and we refined what we have for the entire year, for the entire data, by adapting to warm and cold seasons, because we had different data. We know that, for example, for bathymetry, we have different suitability. If it's warm or cold season, they prefer different depths. So then we go further and we define adapted, let's say, habitat suitability indices for different seasons. In our case, we did only 2, warm and cold. Okay, but that was possible just because we don't have enough information for the cold season that can provide us some models. So we were able to provide this only for the warm season, and for the cold season we are using the annual, let's say, the global model. So this is how it looks finally, the result. So what we have here is, on the x-axis we have the predicted habitat suitability index based on our model with the weights that we define based on in situ calibration data, and on the vertical axis we have the measured efficiency that was measured in situ, of course. And because it's a probabilistic way, I'm not representing here points, because scatter plot as points. I'm presenting box plots, grouping for different categories for each predicted HSE. So we can see that in terms of probabilities, we have some good agreement. Because the way that the model works, it's not, I mean, it's difficult to say. For example, if you have a high predicted HSE, so meaning that you have a high probability of finding fish in that location, but you go and you don't find any fish, that really doesn't mean that the model is not okay, because the model is something probabilistic. It probably means that there are other factors that we do not take into account in our model that finally yielded 0 catches. So that's why we are talking about probabilities, not absolute values. And this is how it looks, the final result. These are just some monthly composites for Whiting, May 2017, October 2010, differences between seasons, of course. And this is what is currently operational. And of course, that's going to be changed. And as I mentioned, for mussels, we had the same approach, but here we had 5 input parameters, but no in situ data for calibration. So we had to rely only on expert knowledge, and not only for setting up these environmental envelopes, but also for setting up the weights for each parameter. So these are the weights that we finally decided in collaboration with the experts from Constanța, and these are the environmental envelopes. And basically, after that, it runs the same as for weighting. These are just some monthly products. Of course, 1 it's mortality, 100 it's best conditions in these maps. And that's it, I think. Yeah.
Thank you. Thank you. Sorry.
Thank you very
You're
much,
welcome.
Sorin. Quite interesting indeed. Okay, so yeah, thank you again, Razvan and Sorin, for the useful tools you just show us. Maybe we can pass to the audience, see if there are some questions and clarification would be provided following this. Just raise your hand. Use I see Slim. Okay. I was thinking about you, Slim, just when looking to this presentation, because I remember our discussion and your pilot. I think it's quite linked to this and what is happening around the aquaculture farms. So, Slim, the floor is yours.
Thank you, Enis. So first of all, I'm sorry, because there is a confusion on the time, so I missed the first hour, but I will look at the record. So I have a question to Sorin. So you said that so Skyfish will be so faster when it will be so installed in a dedicated so Iliad machine. So are you sure that so within Iliad we will have this computer? And so the second question is, can we use so the tools provided by Skyfish through another so dashboard? So for example, I have a dashboard or a tool on which I provide different kind of parameter. For example, the high resolution current and temperature forecast, and I will let's say I would like to add the information provided through Skyfish. So is it so possible to integrate this information or parameter or additional parameter provided by Skyfish through another dashboard? And my third question, if possible to have the answer, I would like to have more information on the language that have been used in order to develop Skyfish. Thank you.
Okay, I will start, let's say, with your third question. So languages, many languages. So for the platform itself, we are using GeoServer, OpenLayers. These are the main solutions, OGC standards, of course. And for the processing part, for the data retrieval part, of course, we are using Motu, which is the way to retrieve CMEMS. It's a Python library that CMEMS is providing, and you can use it in order to retrieve their products. And for the processing part, we are using shell scripts, particular geoprocessing libraries like GDAL and R. I think I've covered most of them. If I missed something, I don't know. But these are the, I say, the most important in terms of.
So it means that for dashboard you are using MapStore.
No, we are using for the client side.
Yes.
To be honest, I don't know for the client side because I haven't been involved in the development of the client side, only on the back server. But it's OpenLayers. It's OpenLayers and the skin. I don't know. I don't remember the skin. What's the?
Okay.
Okay. Your second question. Okay, if you can retrieve the information. Yes, all the layers within Skyfish are available as OGC standards. So you can retrieve them, as I mentioned, WMS, WFS, WCS. You just go to the Skyfish website and you can find there the links that you can use in order to embed these services into your own platform, of course. And anyhow, the OGC standards are going to still, I mean, they are going to be used further in India because OGC is one of the partners, and that's not the reason. The reason is that this is the way to go. But yeah, we're going to provide them as OGC services in the future also. And for your first question, if we are going to have or not DIAS environment, I don't know. I'm also curious. It's not my job to know about that. I also asked the same question to other parties. I don't have an answer. I hope that yes. Otherwise, I don't know. Anyhow, we are scalable. I mean, for me, it doesn't make a big difference. I mean, our pilot case can be run either on my laptop or on DIAS. The only issue is that it's going to be different speeds.
Okay, thank you very much.
Thanks for your questions.
Thank you, thank you.
Thank you, Steve. Yes, Hesam.
Just wanted to interact with you on the questions that was asked by Slim. In case I want to integrate the data that already exists in the Skyfish platform, and I wanted to integrate it in another platform. So is it available right now through OGC like APIs and so on? So I take some of the API links and then put it like in my platform. Is it available? Is it
yes? When I said that all the layers are available as OGC web standards, that means that you can retrieve everything through OGC API, let's say, the web standards. In fact,
is there a link there in your platform, or I need to request it, then you send it back to me, or how it will be available?
To be honest, I don't know if we provide it to the general public. No, I think not. But if you want, no problem. I can provide the links to you or anybody else, whoever is interested. Not sure if it's going to make a big difference because it's what we currently have as operational. As I mentioned, that's going to be improved in the near future. So I'm not sure where the new web standard web services will reside. I'm not sure if it's going to reside again in our premises or it's going to be another place. So, but yeah, if you want them, no problem.
So they are available upon request. Okay.
Yeah.
All right.
Again, these were developed in other. What I discussed today is just the foundation that we are going to, let's say, use in order to further build Iliad case study. So the Iliad case study, I don't know. It's not. I mean, as I said earlier, I don't know. I would like to know where is going to be the main platform that's going to host everything. So if any of you have any idea, then maybe you can share with us.
Well,
maybe Marco Oliveira.
Yes,
it's
I'm
part
here.
of the co-design, I think, in work package 1.
Are you listening to me?
Yes, we hear
Yes?
you, Marco.
Yes.
Sorry, as we have systems of systems approach, in fact, we don't have a centralized platform. Each of the pilots need to have their own infrastructure. What we are aiming is to have set of APIs, just like what you are implementing now with the OGC APIs. Also for the modeling, or running the models, or in fact, we would call it processing applications in the context of OGC. And the data will be available through the data spaces that are being defined in WP4. I was talking about WP5 on the modeling part and the operationalization of the execution of the models. And on WP4, there is a task to define the data spaces. That's the way we would exchange the data and the results. So in situ data and the results of the models. So as a quick answer for your question, each of the pilots needs to have its own infrastructure. There is no central platform for Iliad.
So concerning, for example, the models, so each model will like work apart on itself, then the result of the model will be published in another platforms or the main platform of Iliad. Is this the case? If I understood well.
As I said, the output of the model would reside in the own infrastructure of the pilot, and should be available through the APIs defined for the data spaces. So it should be findable through the data space. Don't ask me more about the API of the data spaces because I don't know it yet. Okay. Right. For the implementation of the application process, the processing applications, so the implementation of the models, what we are working with is defining and using the API, OGC API processes that was previously defined as web processing services, WPS, and we are defining ways to containerize in Docker containers and describing through the use of CWL, the common workflow language, ways to containerize and describe the application so that we can use it anywhere, either through the APIs of the API processes or in a cloud or HPC environment. We showed during the meeting in Rome, first workshop on the use cases and of the ways to containerize the applications. And we are starting now the deliverable, the first version of the deliverable, the D5.1, describing these methods. And we expect to have another workshop probably by the end of June or July, not sure yet, or even September. Sorry, I don't have the dates by heart. On the way of these developments. So we can work with the pilots on these descriptions and on these containerizations. All these models, we expect them to be available on a catalog, similar to the catalogs where you search for the data, for example. We are trying to work with Demus, that's the responsible for task 4.1, to use their catalog, Next.js, to provide the descriptions for the models so that anyone can search for a model. And by using the CWL, you can build pipelines of, so you can build new applications using the results of one model into the input as input for other models. We already have some working examples, but we are trying to build one that will work with the oil spill models, both from Duf, so Georgios, and from Katerina, so Forst. And it is in an initial working example, but we will use this to highlight how to build and how to operationalize this kind of infrastructures. Within the scope of task 5.6, we are also aiming at building one user interface that will allow the users to co-create these applications and get the results as a CWL file also, so that we can run it also anywhere. So this is under development. Task 5.6 just started on month 13. We don't have results yet. This is not easy to develop. And task 5.1, we are working on the deliverable now. So I hope I answered your questions. I don't know if in this context there are any further questions.
Yes, thank you, Marco, for this introduction or overview of the whole process, how it will be done.
I can give you one more hint on this. We are building we have already started this work on creating a technical team that includes people from work package 2, from the technical work packages, work package 2, 3, 4, 5, and 6, to look a little bit more into the different developments that are being technical developments that are being made, and in the scope of WP7, providing also some inputs to the different pilots. So based on the gathering of the technical requirements from the pilots on the scope of WP7, we can also, not at the moment, but in a near future, start answering those requirements from the technical part.
Mm-hmm. So I don't know if it is feasible that maybe, I don't know, just I'm thinking out loud with you, and just a suggestion, if we can provide some, I don't know, examples on how to do it in the near future, building for pilots, or maybe it will be extrapolated to other pilots. Just a small use case on how to do it, like in the near future, whenever the development of such process will be done. So I don't know if we can do it under the work package 10, which is capacity building for
the models. Was that your question?
I did not hear you. Sorry.
Containerization of the models.
Yes, well, containerization of the models and how to, like, from the model or from the infrastructure of the pilot, how we can like extrapolate it into the main system or like of the results and data and everything. So I don't know if it is feasible or it will take too much time. I don't know. Just a case study on how to do it, or how that could be integrated. Mm-hmm.
You can start by because I was trying to understand your question. I think you can start by looking into the presentations that we did on Rome. I think it's within a folder. Sorry, I will look into. I think all the presentations are in the Intersoft SharePoint, and they should be under work package 12. Sorry, where do I have this open?
Second meeting telcos, I think.
Yeah.
Plenary meeting Rome. Is that it? Rome, January.
Yeah. Sorry, I was trying to access the Intersoft SharePoint, but it seems I lost. Access denied. I don't have permission at the moment to access Intersoft SharePoint. I will try it later. But I do think that it is under work package 12, second plenary meeting or something like this, WP5 workshop. It should be there. And you should find there 4 presentations, one by me on the use cases, one by Piotr from OGC presenting the API, the OGC APIs, another one from Fabrice from Terra2, showing how to build how to create a processing application, so how to containerize the workflow pipeline, and another one from Katerina from Ford, describing the work that has been done within the scope of task 5.4 and identifying which of the models should be containerized because of a certain set of properties that we identified make them required to be containerized. For example, if a model is to be run by different pilots, then or is interesting to be shared by these different pilots, then we should containerize it so that we can facilitate their reuse in a different context. As I said, we are working on also on an example of these on building these pipelines. We have already showed a simple example during this review period meeting with the European Commission and the reviewers, and this should be also available as soon as we finish or have the deliverable 5.1 in a status that can be reviewed by the partners. So I would say not at the moment, but in the scope of 1 month or 1 month and a half, we will have these examples available.
All right. Thank you.
But you can start by looking at those presentations. or even our presentation, WP5 presentation on the review meeting. I do think that you can access it also in the scope of WP12.
Under which folder in WP12?
It should be
Which one? Meeting?
On review meeting, first review meeting or something like this. As I said, I don't have access at the moment to the SharePoint. Not sure what happened.
Okay.
But it should be there.
Okay. Thank you, Marco, for this reminder and also the overview. I don't know if there are other questions from other participants. Otherwise, maybe I will use the opportunity as I'm talking. I have a question related to maybe the first tool, but even the other ones. I mean, the forecoast tool. I think there are a lot of useful links possible. Maybe it's already ongoing within pilots. Just use the opportunity as Slim is with us to remind that what Slim is developing within the aquaculture monastery pilot is a modeling based on data, based on sensors, on how to make the feeding of fish within the aquaculture cost effective and environmentally friendly. And if I remember well, also from Rome workshop, the aquaculture Norway is also something developed within an aquaculture farm to make cost-effective cleaning of the nets and the cages. As far as I understood from your tool, it's quite helpful because it's providing what is happening around or could happen around the fish farms. I saw that it is based on the satellite data, on time series data. I just wanted to understand if there is also, buoys with the sensors around that area. And if so, yes, Razvan?
In that area, we have 2 buoys, so only waves.
Okay.
And in the near future, we should have also 2 IDCPs. Also installed during Iliad, probably this summer. But the problem in Black Sea is continuity. It's a very highly productive sea and a lot of biofouling, and it's required a lot of maintenance. That's why sometimes the data are not continuous. In this case, we expect to have better continuity, but it's a huge task.
Okay,
but
these buoys are set in a way to allow having data on the whole area, not in the dedicated fish farm. I mean, it's not the private company.
Yes, it's a free available voice and can provide. Okay. So there are two spotter buoys providing waves, parameters, and also surface temperature. They're floating buoys, GPS buoys, like Wave Rider, and it provides also sea surface temperature. But these are very easy to maintain. But all IDCPs we placed in this area, Western Black Sea coast, is very easy closed, and sometimes needs divers and a lot of expenses from here. That's why the continuity of data is a big issue here. But let's hope this year we'll have an extension of these buoys from another projects also. So there will be another extensions from different provider. It's the Jerry Kumar Research Institute in Geology, and they will have another additional 2 such buoys. And there is also ENSO Enzo networks with 3 buoys, but in offshore area. In this case.
Okay.
This area. Yes.
Okay. Thank you. No, I see really good linkages, because what you are doing outside the, let's say, aquaculture area, and what will be done in other pilots inside the fish farms could be quite complementary. And even the I swim with the jellyfish pilot, I see quite a good link there.
Yes.
So I see Slim raising the hand. I go back to Slim, and later on I have another question. Slim?
Just if possible, can you have another demonstration of skyfish, but in another area? Quick demonstration, just how to define the area of interest and to display a parameter.
Is it a question for me?
Yes.
If we can have something similar in other areas?
Yes.
Well,
so any other area?
Yes, the general question, yes. If you are referring if we can have these sort of things within the context of Iliad and the activities that Terracina is involved in, no. But in general, yes.
No. I meant in the frame of this webinar.
You mean a practical demonstration?
Yes.
Okay.
Yeah. So because it seems that when we choose an area of interest, it move every time to the Black Sea. So I don't have any
because it's
experience
specifically
now.
designed for the Black Sea. We don't have any other areas. The models, as I mentioned during my presentation, the models are calibrated for that particular area, the Western Black Sea, and the service from the beginning was designed for that particular area. So there are no other areas involved.
Okay.
Yes, it was the purpose of this tool. I mean, it is now developed and designed for the Black Sea. And of course, later on, if there is any interest, it could be, adapted to another region and for similar aspects. This is what I think, from the presentation, what we understood and what colleagues want to show, that this was developed for one particular purposes, but later on, of course, if there are interest, we can explore, and it will be easier because already there is this architecture already there, and big part of the work is already done. I mean, this is as far as understood.
A similar service can be provided for any other area. The only setback, the only question mark is if we have enough in situ data in order to calibrate regional models. That's the question. If we have in situ data, useful in situ data, not aggregated yearly or monthly catches, but particular profiles, then yes, we can build something identical to Skyfish or any other area.
So
the problem is the model.
No, so I'm not referring to fishing data. I'm referring to environmental parameters that can be displayed through Skyfish. So is it straightforward to define another area and to use the Skyfish in order to display the environmental parameter, the SST or the salinity or any other parameter available through CMEMS or
yes,
or
but
satellite sensor?
So yes, the question, yeah, it could be done. I mean, if you want to see SST in your area, yeah, we could add that in Skyfish with more or less effort, not that complicated. The idea is the following: we are showing SST in combination with habitat suitability index, because as a fisherman, as a user, I want to see the habitat suitability index first of all, and then I might want to see also the environmental parameters related to fishing, temperature, salinity, whatever. It doesn't make, to me at least, doesn't make much sense to build something that shows only CMEMS products as long as you have CMEMS. So if you want just to show CMEMS, of course, we have, let's say, a little bit of more functionalities in Skyfish than CMEMS, but CMEMS is catching up. So if you are just looking after the essential oceanographic parameters, I would say go to CMEMS. That's my question, my answer.
No, so I think that so CMEMS so provide the data, but so CMEMS does not provide this displaying so capabilities.
Yes, they do.
Maybe.
Okay, so I think we are behind the time schedule, but not even we start 5 minutes later, so we can have still 2 or 3 minutes. In any case, we will have the second session tomorrow to continue with more practical examples too. I don't know if there is another question. Slim, I see your hand. Is it another question or?
No, sorry.
Okay.
Some
Yes,
people can ask by writing. It's also possible.
Yes, it's also possible by writing. Maybe I have a question related to the index. I mean, the habitats, the suitability index. Is it based, I mean, on an exploitation, for exploitation purposes? I mean, is it taken into consideration the ecology of that priority species? Because habitat suitability could be something, I mean, habitat could be suitable for reproduction, it could be suitable for some vital needs for the species, as it could be also an index for fishers to say, look, there are all the suitable conditions to found that species in that area on that time. So you can make your fishing activity more cost effective. So is it based on both or mainly on the exploitation side?
Second version, exploitation part.
Exploitation, okay. So taking into consideration, and it could be also used, I don't know, if I would have aquaculture on one specific species, could it help to determine an aquaculture suitable area in that case?
Yes.
Okay. Okay, so that is the double purpose, let's say, from this.
Yeah, as I showed, we are providing also for aquaculture. It differs the parameters that go into the model, and yeah, you have to have some. I mean, it's not perfect because it's based on expert opinion. It's not calibrated with any in-situ data because you don't have those, at least for our area. But still, it provides a general overview. I mean, what's the fluctuation of the conditions? I mean, do I have optimal conditions throughout the year, or do I have optimal conditions just 2 months in 1 year, or things like that? Yeah.
Okay. Any other question? I don't see other questions, so if not, maybe just to to say thank you all. And of course, there will be the recording of this session, and tomorrow the same. We'll be recording and sharing later the session. So tomorrow, just to avoid any confusion, the same time, I mean 2 p.m. Central European time. And it will be also two hours, let's say, session. And probably we will have more practical, also additional, let's say, practical examples, and we'll be having this possibility to further interact and better understand these very, very useful tools, even if they are now, as you saw, developed for the Black Sea, but probably this is one of the aim of the Iliad project, to explore possibilities for adaptation of some relevant tools to other regions and make other stakeholders, of course, highlighting their needs and supporting further development of these tools in other areas. Okay, so see you tomorrow. Thank you all. See you.
Bye-bye.
Thank you so much.
Bye.
Bye-bye.
Bye. Thank you. Bye-bye.
Thank you. Bye.
Bye bye. Thank you.